This is going to be the third video that I'm doing in the process of making a swivel adapter for the gem double-faced DTI, and I've already started knurling. First of all, I've decided that in my other video, the recent video, I mentioned that I was going to drill some holes through and just copy the same design as the purchased one that I bought from eBay to fit the ball, and I decided that I'm not going to do that. It's not really necessary for the thing that I need it for. I just need to be able to swivel the indicator around its pivot point just ever so slightly, just so that I can maneuver the stylus, surface of the stylus, in the right position on the, either in the hole bore or on a peg, or even on finding an edge of a plate or a job that I'm doing. So I'm going to eliminate the holes. They're not really necessary. So what I've done so far is, in my previous video I'd already tapped the hole, and what I've done now is I placed a 1/4 inch bull-nosed end mill in, and held it in the chuck, drill chuck, and I've just formed a radius, a 1/4 inch or 1/8 radius surface at the bottom of the hole. That will be a good contact surface for the ball when it's all assembled and together, and it should make a smooth movement until I nip it up in the position that I want. So anyway, what I've done is I've started making the knurl, and I haven't done a lot of knurling, certainly on the TAG with this unit, and I already had straight knurls in there, so I thought, well, I'll just make it with a straight knurl. It's a fine knurl, and I've started doing the knurl and it's almost finished. I just thought I'd show you how this knurling tool works. When I'm knurling, I try, if possible, to get the front face of the knurl itself cutting like a tool bit, with slight clearance behind, so that in actual fact it's not exactly square on with the face of the chuck. There's a slight angle to the knurl as it passes along, and so the idea is that it cuts at the very beginning, and it just kind of, hopefully, knurls, just fits into the groove, and just follows. That's how I've done it. I've done knurling on when I was at work, but that was a special knurling tool where the two wheels were set together at an angle, and they actually did machine the knurl off, so it was just the front. But that was a very, very expensive tool. It had gauges on it and dials for setting the diameter, the correct diameter of the part that you're knurling. But this is just basically an ordinary knurling tool, but that's what I try to do. I do the same with when I'm machining acrylic. I mean, obviously I have a negative top rake on the tool bit, but what I do is I grind the tool so that it's flat at the on the very front face, and then when I'm machining, most of the material is taken off at the front of the tool bit, but the back of the tool bit, the front face, the back of that is actually kind of skimming, like a shear, you know. So I found that with doing it that way with a lubricant of some kind will tend to give you a nice like very clear, like glass surface. So just things that I do. I'm sure everybody does it all different, but that's how I tend to work, because that's what I've always done, and so it seems to work for me. I learned a lot of my stuff from old tool and die makers, the old boys that I stood beside when I did an apprentice. I worked alongside a qualified tool and die man, probably getting towards his retirement age, who had a vast knowledge of experience and would give you little tips about doing this and doing that. One of the tips that I learnt was drilling a hole with a drill bit, say, I don't know, a 1-inch drill bit, and getting a nice circular hole in thin sheet material, and almost getting it to size. And people laugh, I guess. If you get a piece of rag, you drill a small pilot hole in the plate first. I'm talking about maybe a 30-second steel plate, something like that. And of course you have to clamp it down on the table. But once you've drilled the pilot hole, then you want to drill it, say, 7/8 or 1 inch. And if you get a piece of rag, and I don't know how true this is. I've done it. I've used the idea. You turn the rag over into 4 pieces, and you place that over the pilot hole, and then you come down with your drill, and instead of the drill giving you a triangular hole, it'll give you a nice round hole. I've also used things like this for drilling, like a countersink, and use that to drill into thin sheet, and you'll get almost a perfect size according to the diameter of the outside of the countersink. So all little things that really are not in the book, but that you learn as you go along and work with other people, and that's how you gain a lot of your experience in such a way. So anyway, we'll get back to the knurling, and it's like I say, it's a fine knurl, and it doesn't have to be really sharp, but at the moment I've got it running freely, and it's just in the grooves, what I do is, with this tool, is you put your cut on with that, and then when you've finished, you can lift this up and you can wind it along to another spot, and without touching this, it doesn't interfere with the splines, and then you re-engage this, and that will give you the same depth on both knurls. So anyway, this is a Knurling DC motor with the control, and really it could do with a stronger motor, a bigger motor. I find that it may be the belt as well that doesn't help, but like a better belt, a wider belt, maybe a tooth belt, would probably benefit from that. But it's kind of, to me, I think it's underpowered slightly. So what I have to do is I have to increase the speed as I increase the cut, because it slows the motor right the way down until it will almost stall, you know. So I'm going to switch it on now, and it's running. So I've got it at 100, just over 100 RPM. Now another thing that I do is when I start off, I try to get the wheels, the first 16th or 1/8 of the wheel on the blank shaft, and then I increase my cut there so that the whole wheel is not trying to dig in. It's just digging in to give the form at the front edge. So that's another thing that I do. I don't know whether that's normal. It probably is, even with the more sophisticated knurling tools. But anyway, that's what I do, and then I'll increase the feed a little bit. You can hear it slowing down, and then I just put the auto feed on, and I've got some lubricant here, and when I've done this cut, I'll run it back a few times, backwards and forwards, to help to clear any little bits of grit cuttings that I think it'll come out okay. The thing that I like about these tools is the old-fashioned tools were like two wheels that were fixed together, close together, and you would line the centre line of the tools onto the job, and then wind in the top slide, top slide. No, not top slide. Oh, see, brains going. Oh boy, the cross slide. Cross slide. Wow, don't get old. The cross slide, and although it worked, and I guess it was okay on bigger machines, but it tended to put an awful lot of pressure on the spindle bearings in one direction, and I don't know, just my theory that if you can use a tool like this, you're better off, because there doesn't seem to be any strain on the spindle, only on the motor or the drive, and saves your spindle bearings. So I guess I could have put it on a faster feed, but you don't want to put it on too fast, then you may tend to get a wavy line instead of a wavy groove instead of a straight groove. So what I'll do now, times, put some juice on it. Okay, I think that'll do. I'm going to take that off now and see what it looks like. Yeah, that's pretty good. I'll take it out and blow it off, and I'll get it closer to the camera. Hang on, I'll wait until that thing switches off. There we go. Okay, so this is the knurl. Hasn't come out too bad. I'll take a look at it under the glass. And yeah, flushing is one of the important things on knurling. There's a few little bits and pieces that you can see with the glass, but not so obvious when you're looking at it, I don't know, put away. Looks pretty good to me. It's good enough anyway. Okay. Look at the ear. Look at the fingers. Yeah. There you go. And so this is the dial. And here's the nut. There's the nut. Now I'm going to have to face some away from the front face of this part. Not too much, but I need to be able to have a gap between there and the body of the indicator when the ball makes contact between the two parts, so that I can tighten it up. So it's probably going to be maybe about that wide, maybe 3/8 of an inch, something like that. I'll have to wait and see. It will all determine how far I went in with the ball end mill. So I need material at that end to stop the ball from coming out. So that's something I'll have to check out. So there you go. That's another part towards making it. And to all intents and purposes it's not far off being finished now. I have to turn the shank of the ball down and shorten it as much as possible, because that helps with the height of the Taig milling machine, the amount of clearance there is between the Z-axis and the table. So the shorter the better. So this is going to be turned down to about 532. I'm going to turn that down to 532, and I have a split bush that I'm going to put over it after, that fits the 532 and extends the diameter out to 250, because that's what the hole is in my adjustable tooling that holds the dial indicator. So that's probably one of the jobs I might do next. I guess you'll find out next time I do a video. Okay, I'm going to call off now. Thanks for watching, and thanks for all the positive remarks from my previous video, the part 2 of this. I'm quite surprised at the amount of people that actually viewed within less than 18 hours. So that's very promising for me anyway. So there you go. Yep. Okay, calling off. Thank you. Huh.